So we're going to look at Einstein's equation, E equals mc squared, and we're going to use that to find the amount of energy produced when, say, nuclear fusion occurs. And this can occur in the sun, which is what we looked at in the lesson. It also occurs in nuclear power plants. So let's say in a nuclear power plant, over the course of a day, 2 grams of uranium is converted into energy. I want to know how much energy, E-N-E-R-G-Y, how much energy does that get? Some things we have to know about. Mass in this equation, E equals mc squared, mass has to be measured in kilograms. And you'll notice I gave you a mass in grams. C is the speed of light. That's 300 million meters per second. Doesn't matter if it's a radio wave, a light wave, or a gamma ray. They all travel at 300 million meters per second. That's 186,000 miles per second, by the way. It's around the world about 7 times a second. And then E is energy, and energy is measured in joules. So the first thing I do with this 2 grams is remember, kilo means 1,000. So there's 1,000 grams in 1 kilogram. And so 2 grams is 0.002 kilograms. So I have my mass, 0.002 kilograms, and I know C, 300 million, which I'm going to write as 3 times 10 to the 8th meters per second. And then I have E, which is what I want, which is just mc squared. So then let me show you how to do this on a calculator. So what I need to do is take E and set it equal to 0.002 times 3 times 10 to the 8th squared. Now, I could type that all in on a calculator, but there is this cool E button. I see it here above my comma. So I'm going to type what I see, 0.002, and then parenthesis, and then 3, and this times 10 to the power of 8. I use this E feature, and then I just put in the power. And then I can square that and push solve or enter or equals, and it tells me that this is 1.8 e to the 14. You're not a calculator, so you don't get to write e. You get to write 1.8 times 10 to the 14th power. 1.8 times 10 to the 14th joules of energy.